Right now, while you are watching this, something is happening far beyond the edge of our solar system that almost nobody on Earth knows about. A machine we built 47 years ago just sent back a message that changes what we thought was protecting us. It found a crack, a leak, an opening in the invisible wall that wraps around everything we have ever known. This wall was supposed to be sealed. It was supposed to keep the dangerous radiation of the galaxy out. But it does not. And what is slipping through that crack has been shaping life on Earth since the very beginning. This is the hidden story of what Voyager 2 really found at the edge of our solar system. Welcome back to Proof, where we uncover the hidden truths of the cosmos. If you are new here, hit subscribe now, because what you're about to hear, most people will never know. Let us go back to the summer of 1977. The world was different. There were no smartphones, no internet, no GPS in our cars. The space race had cooled. The Apollo program was over. NASA was looking for the next big thing. And they found it in a rare alignment of the outer planets that happens only once every 176 years. Jupiter, Saturn, Uranus, and Neptune were lined up in a way that allowed a single spacecraft to visit them all, using one planet's gravity to slingshot to the next. They called it the Grand Tour. But funding was tight. The government only approved a scaled-down version. 2 spacecraft built to do a quick tour of Jupiter and Saturn, and maybe, if they survived, Uranus and Neptune. And then they were supposed to just drift off into the darkness forever, silent and alone. Voyager 2 launched first, on August 20th, 1977. Voyager 1 launched 16 days later on September 5th. They took different paths. They headed in different directions, but they shared one destiny. They were going to fly farther than anything humanity had ever built. Nobody expected them to last this long. Nobody expected them to still be talking. And absolutely nobody expected them to shatter our understanding of the invisible shield that protects our world. Drop a comment right now and tell me where you are watching from, because this story connects all of us, no matter where you are on the planet. Over the years, they flew past the giant planets. They sent back stunning photographs. They discovered moons we did not even know existed, volcanoes on Io, geysers on Triton, a storm on Neptune that moved faster than the speed of sound on Earth. And they just kept going. By the time the 2000s arrived, they were farther from Earth than any human-made object had ever traveled. And still, the instruments worked. Still, the data came back. Still, NASA listened. But to understand what they found, you need to understand what they were flying toward. You need to understand the heliosphere. Because without that, none of what comes next makes sense. The sun is not just a ball of fire sitting in the middle of space. The sun is constantly exploding. Not the kind of explosion that destroys things, but a constant, endless outward rush of charged particles. Electrons, protons, high-speed plasma. This is called the solar wind, and it blows in every direction all the time at roughly 1 million miles per hour. This solar wind does not just disappear into nothing. It pushes outward past Mercury, past Earth, past Mars, past Jupiter, past Saturn, past Uranus, past Neptune, past Pluto, and it keeps going for billions of miles. It carves out a massive bubble in the space between the stars. That bubble is the heliosphere, and we live inside it. Everything inside that bubble is protected. Everything inside it exists in the sun's magnetic domain. The solar wind creates a kind of invisible shield around all the planets. And what is it shielding us from? Galactic cosmic rays. These are high-energy particles fired across the galaxy by dying stars, supernova explosions, and other violent cosmic events. Without the heliosphere, those particles would slam into Earth constantly. Scientists believe they would increase the mutation rate in living things. They would damage DNA. They would make life on this planet far more difficult. The heliosphere is not just interesting. It is the reason life as we know it can exist here. The outermost edge of this protective bubble, the very last point where the sun's influence still holds, is called the heliopause. Beyond it is interstellar space, the space between stars, a different environment entirely, colder, denser, filled with particles from sources that have nothing to do with our sun. Before Voyager, nobody had ever been there. Before Voyager, nobody knew exactly what it looked like, how thick it was, whether it moved, or whether it was completely sealed. Think about that for a moment. We sent these probes out into the dark, hoping they would reach the edge of everything the sun controls. We did not know what they would find. We had models, we had theories, we had math, but we had never been there. We had never touched the wall. In 2012, Voyager 1 crossed the heliopause. It became the first human-made object in history to enter interstellar space. The instruments detected a sudden drop in solar wind particles. Cosmic rays from outside surged. The magnetic field shifted. It was a crossing, clean, measurable, historic, but there was a problem. Voyager 1's plasma instrument, the tool that could directly measure the plasma around it, had stopped working back in 1980. A heater malfunctioned. The instrument froze. So while the data told us Voyager 1 had crossed the boundary, there were gaps. Key measurements were missing. Scientists had to piece things together from other instruments. They could infer the plasma density, they could estimate the temperature, but they could not measure it directly. They were guessing, educated guessing, but still guessing. That is where Voyager 2 becomes the more important spacecraft. Because Voyager 2's plasma instrument was still working, fully operational after more than 40 years in space. It was the only tool we had that could directly sample the environment on the other side of the wall, and it was about to give us the shock of a lifetime. On November 5th, 2018, Voyager 2 crossed the heliopause. It became only the second spacecraft in history to enter interstellar space, and this time, for the first time ever, NASA had a fully functioning plasma spectrometer on the other side of our solar system's boundary. The data that came back rewrote the textbooks. The first thing Voyager 2 confirmed was the crossing itself. The plasma science experiment, which measures the speed, density, temperature, pressure, and flow of surrounding particles, detected a sudden, steep decline in solar wind on that exact day. Before that date, the probe was swimming in solar plasma. After that date, the solar wind was gone. Completely gone. That single measurement gave scientists something Voyager 1 never could: direct proof from inside a working instrument of the exact moment the transition happened. And unlike Voyager 1, which took about 28 days of going back and forth near the boundary before finally crossing, Voyager 2's crossing was almost immediate, less than a single day. The boundary it crossed was thinner, more abrupt, sharper. This was the first hint that the heliopause is not uniform. It is not the same everywhere you look at it. Different regions behave differently, and that matters enormously. Now here is where things get strange. Scientists had a model of what the heliopause would look like from the outside. They expected that when either Voyager spacecraft crossed into interstellar space, the magnetic field would change direction. The sun's magnetic field points in a certain direction. The galactic magnetic field, the field threading through interstellar space, was expected to point in a very different direction. Crossing the heliopause should have been like walking from one room where all the arrows on the walls point north into another room where all the arrows point east. You would expect the arrows to suddenly change direction. Voyager 1 crossed. The magnetic field direction did not change significantly. Scientists were confused. One data point can be a coincidence. Maybe Voyager 1 crossed in an unusual spot. Maybe it was a fluke. Maybe the boundary was warped in that specific location. But then Voyager 2 crossed at a completely different location, on the opposite side of the heliosphere, in the southern hemisphere, versus Voyager 1's northern exit, 6 years apart, in a different phase of the solar cycle. The magnetic field direction still showed no significant change. This was not a coincidence. This was real. The magnetic field lines just outside the heliopause run parallel to the magnetic field lines just inside it, at two completely different points on the boundary, 6 years apart. This challenges fundamental assumptions about how the sun's magnetic influence ends and the galaxy's begins. It suggests that at the boundary itself, the two fields are somehow aligned, something no model had predicted. Nobody fully understands why, and nobody is pretending they do. But the magnetic field surprise, as stunning as it is not the crack. The crack is something else entirely. Here is the part they did not fully explain. When Voyager 2 crossed the heliopause and entered interstellar space, its instruments kept detecting something they were not supposed to detect: solar particles. Particles from inside the heliosphere. Particles that should have been stopped by the boundary. They were leaking through. Scientists at NASA's Jet Propulsion Laboratory confirmed this. A trickle of solar particles was slipping through the heliopause and into interstellar space. The boundary was porous. The hull of the heliosphere, to use NASA's own analogy, was leaky. Now Voyager 1 had seen something different. Before it crossed the boundary, it detected interstellar particles punching inward into the heliosphere, what scientists called interstellar flux tubes. Essentially, channels where outside particles managed to get in. So Voyager 1 saw particles coming in from outside. Voyager 2 saw particles leaking out from inside, both directions. The heliopause leaks both ways. This is where the geometry matters. Voyager 1 exited near the very front of the heliosphere, the leading edge, the part of the bubble that faces the direction the solar system is moving through the galaxy. Voyager 2 exited closer to the flank, the side. And the flank, the data shows, is more porous, more permeable, more like a cracked wall than a sealed one. NASA's own JPL report described the heliosphere as having a leaky boundary. The heliopause, it turns out, is not a hard shell. It does not stop everything. It is a dynamic, imperfect, breathing boundary. And Voyager 2 was the first probe ever positioned to prove it. And then there is the temperature. This is the detail that does not make sense on paper. And yet, it is real. Scientists expected the temperature at the boundary to be relatively cool. Instead, Voyager 2 measured temperatures inside the heliopause of 30,000 to 50,000 Kelvin. That is hotter than the surface of the Sun. How can the edge of our solar system be that hot? Scientists believe the heat comes from compression. When the outward moving solar wind meets the inward pressure of the interstellar medium, particles on both sides bunch up. They slow down. And when particles slow down in a compressed zone, they heat up dramatically. Think of squeezing air into a tire. The air gets hot. The same physics, but at a solar system scale, the heliopause is not just a boundary. It is a zone of extreme energetic activity. A compression region where two cosmic forces, the Sun's outward push and the galaxy's inward pressure, are in constant collision. Here's another thing that surprised scientists. Both probes measured the distance at which they crossed the heliopause. Voyager 1 crossed at 121.6 astronomical units from the Sun. 1 astronomical unit is the distance from Earth to the Sun, about 93 million miles. So Voyager 1 crossed at roughly 11.3 billion miles away. Voyager 2 crossed at 119 astronomical units, about 11 billion miles. Almost the same distance, very close. Why is that surprising? Because they crossed at different times, 6 years apart. And the Sun's activity was completely different. Voyager 1 crossed during solar minimum, when the Sun is relatively calm and the solar wind is weaker. Voyager 2 crossed during solar maximum, when the Sun is far more active and pushing harder. Scientists expected the heliopause to be at very different distances depending on solar activity. They imagined it expanding and contracting like a lung with the Sun's breathing. But both probes crossed at almost the same distance. The model said the heliopause would move significantly based on the solar cycle. The data says it barely moved at all. We do not understand why. The boundary seems more stable than predicted, more fixed, but also more permeable. It is a strange combination, steady in position but leaky in function. If hidden stories like this are why you come here, subscribe now, because we are just getting started. Now, here is something that deserves a moment of quiet attention. Both Voyager probes also found that the heliopause only lets in about 30% of the high-energy cosmic rays from the rest of the galaxy. That means it is blocking roughly 70% of the radiation that the galaxy throws at us. And scientists have pointed out that this 30% that does get through has real biological implications. It has, over billions of years, contributed to the mutation rate of life on Earth. Think about that. The cosmic rays that leak through our cracked solar system boundary, through a boundary we now know is porous, those particles have been influencing life on this planet since the beginning. They have been contributing to the genetic changes that drive evolution. The imperfect shield is not just an interesting scientific detail. It is woven into the history of life itself. Let that sink in. The galaxy is not just out there, far away, disconnected from us. It is here. It is inside us. The radiation that slips through the cracks of the heliopause has been striking the Earth for billions of years. It has been striking the oceans. It has been striking the soil. It has been striking the DNA of every living thing. Some of the mutations that radiation caused were harmful. Some were deadly, but some were useful. Some drove evolution forward. Without those mutations, without that constant tiny pressure from the outside, life on Earth might look very different today. We might not be here at all. This is the hidden truth that Voyager uncovered. We are not isolated. We are not sealed off from the galaxy. We are in a constant, quiet exchange with it. The galaxy breathes on us, gently, through the cracks in our shield. And that breath has shaped who we are. Because Voyager 2 had a working plasma instrument, and Voyager 1 did not, Voyager 2 gave scientists something completely new. It measured the actual temperature of the interstellar plasma directly. Not inferred, not calculated from secondary instruments. Directly measured. The number came back colder than the plasma inside the heliosphere, which makes sense, but still hotter than expected for the undisturbed interstellar medium. Still in that 30,000 to 50,000 Kelvin range that nobody predicted. And the density. The plasma outside was found to be significantly denser than inside. Voyager 2 measured interstellar plasma at 20 times denser than the solar plasma it had been traveling through. Voyager 1, at a different location, measured it at 50 times denser. Different spots, different ratios. Another sign that the boundary is not uniform. The two probes are looking at the same boundary from two different angles, and they are seeing different things. Not contradictory things, but different things. Like two people standing on opposite sides of a building. They are describing the same structure, but it looks different from where they are standing. There is one more thing. Voyager 2 revealed that may be the most profound of all. After crossing the boundary, Voyager 2 did not immediately reach clean, undisturbed interstellar space. Instead, it found itself in what scientists describe as a perturbed transitional region, a zone just beyond the heliopause that has been stirred up, where things are not settled, where the properties of space are still being shaped by the heliosphere right next to it. Scientists now believe both Voyager probes, even though they are technically in interstellar space, are not yet in the true undisturbed interstellar medium. They are in a transition zone, a buffer region, a space where the heliosphere's influence is still being felt, where its magnetic fields drape outward, where its particles leak through, where its presence distorts the environment around it. According to scientific analysis, Voyager, one may need to travel for another 60 years, covering roughly 20 billion more miles before reaching the completely undraped interstellar magnetic field. Voyager 2, traveling in a different direction, may need twice as long, over 100 years more. The edge of our solar system is not a line. It is not a wall. It is a vast, complex transition, a negotiation between the sun's influence and the galaxies, and it extends far further than most people imagine. This is a twist that hardly anyone talks about. We crossed the boundary, we celebrated, we said we made it to interstellar space, but we did not. Not really. We are still in the sun's shadow. We are still in a region where the sun is pushing back against the galaxy, where the magnetic fields are tangled and draped and twisted. We are in the shallows, not the deep ocean. The true interstellar medium, the untouched, undisturbed space between the stars, is still decades away, maybe over a century away. The edge of our solar system is not a door you step through. It is a long, slow, messy hallway. And we are still walking down it. Now, let us zoom out. Let us look at what all of this actually means. We built a machine in 1977. We gave it a nuclear battery, a radioisotope thermoelectric generator that slowly converts the heat from decaying plutonium into electricity. That generator now produces about 250 watts of power, less than 3 standard light bulbs. And from that tiny trickle of electricity, Voyager 2 sends radio signals back to Earth at just 160 bits per second, slower than the internet connections of the early 1990s. The signal travels at the speed of light and still takes over 17 hours to reach us. There are 70-meter antennas pointed at this spacecraft right now, one in California, one in Spain, one in Australia, all part of NASA's Deep Space Network, all built to pick up a signal so faint that it carries almost no energy by the time it arrives. But that signal still carries real scientific data from beyond the edge of our solar system. This is possibly the greatest engineering achievement in human history. Not for its technology, because by any modern standard, the technology is ancient, but for its longevity, for its reach, for the fact that something we made is sitting in interstellar space and still talking to us. Think about the people who built this. They are in their 70s and 80s now. Some have passed away. They built a machine on a drafting table with pencils and slide rules. They programmed it with punch cards, and it is still working. It is still out there, pushing into the unknown, sending back messages that rewrite our understanding of the universe. That is not just engineering. That is a love letter to the future. That is faith. Faith that the machine would last. Faith that the antennas would still be listening. Faith that someone, decades later, would still care about what it had to say. And what it is telling us changes things. We thought the heliosphere was a sealed bubble. It is not. It is a leaky, dynamic, complex boundary that breathes and fluctuates and allows particles to pass in both directions. Our solar system is not hermetically separated from the rest of the galaxy. There is exchange happening at the boundary, there is interaction, there's porosity. We thought the temperature at the boundary would match our models. It does not. It is twice as hot. A blazing wall of plasma energy at the edge of everything we call home. We thought the magnetic field would change direction when you cross the heliopause. It does not. The fields on both sides run parallel. A discovery that forces us to rethink how the sun's magnetism relates to the galaxies. We thought the heliopause would move significantly with the solar cycle. It barely moves. The word crack is not a word from a NASA press release. The real word is porous, permeable, leaky, but the meaning is the same. The wall around our solar system has openings. Particles come in, particles go out. The exchange between our solar system and the rest of the galaxy is constant. What we live inside is not a fortress. It is more like a permeable membrane, one that filters a lot, but is far from airtight. That does not mean we are in danger. The heliosphere still blocks most of the harmful radiation. Life on Earth is not threatened by these findings. The protection is real, but it is imperfect. And imperfect protection means the galaxy has always had a small but measurable influence on everything inside, including us. The cosmic rays that sneak through are not enemies. They are part of a larger story. They have shaped evolution. They have contributed to the genetic diversity of life. They have been quietly participating in the story of life on Earth from the very beginning. The mission was supposed to end decades ago. The power is running low. Engineers have had to turn off instruments one by one to conserve what is left. The heaters are off. The margins are razor thin, but the data keeps coming. In November 2026, Voyager 1 will reach something remarkable. One light day from Earth, one full day's travel for light. That is over 16 billion miles away. It will be the first time a human-made object has been that far from home. These probes have exceeded every expectation, every lifetime estimate, every prediction about how long they could function. And here's the thing that pulls it all together. We live in a solar system that is hurtling through the Milky Way galaxy at roughly 490,000 miles per hour. As it moves, the heliosphere plows through interstellar space the way a ship plows through water, with a bow wave, a compressed leading edge, and a long trailing tail. The sun's bubble is not a perfect sphere. It is more like a teardrop shaped by the direction of travel, and the flanks of that teardrop, the sides, are more porous, more open, more permeable. This is exactly where Voyager 2 crossed, and this is exactly where it found the cracks. A spacecraft launched in 1977 before personal computers, before the internet, before GPS, a spacecraft running on less power than your bathroom light, traveled over 11 billion miles, crossed the edge of our solar system, and sent back data that rewrote our understanding of where we live. The wall has cracks. The boundary breathes. The solar system is not sealed. And in the most beautiful possible way, this means we are not alone in a sealed bubble. We are connected to something much larger. The galaxy's particles have always found their way to us, and ours have always leaked out. We are part of the Milky Way, not just because we orbit inside it, but because the boundary between us and the rest of it has never been perfectly closed. Voyager 2 spent 41 years getting to the edge of our solar system. It crossed in less than a day, and what it found on the other side took everything scientists thought they knew and turned it inside out. That is science. That is exploration. That is what happens when you build something pointed at the void and have the patience to wait for an answer. The answer came back. And the answer is, it is complicated. It is surprising. It is hotter than expected, leakier than expected, and stranger than anything our models predicted. And that is the best news in science, because when reality surprises us, it means there is still so much left to understand. Tell me in the comments what you think is really out there. Share this with someone who still looks up at the sky and wonders. And as always, thank you for exploring the hidden universe with proof.